Right, hi Alexia. So this is question 21 of the non-calculator analysis, and I've written it up on the screen. It's asking for an indeterminate integral, so that's where you integrate the function, but you don't do anything else with it. You're not putting any values. You haven't got any limits to put in there. You're not finding an area or anything. So it's just where you integrate it and you put your plus c at the end to show that there could have been a constant. And it looks complex because you've got all these different things going on, but when you've got a combination of things in a function, then you integrate them one at a time. So here we're gonna integrate the 2e to the x first. We're going to integrate the minus x, and then we're going to integrate the 4 over 2x plus 5. So what I'm going to do is I'm going to pause it and do it a bit at a time because it's not really smooth. Okay, so first one, 2e to the x. Well, e to the x is the only function that differentiates to give itself. E to the x gives e to the x. I've got two lots of it. 2e to the x would just differentiate to give me 2e to the x. If it's 3x example, then when I differentiated it, I'd get e to the 3x, but I'd have to times by the 3, so I'd end up with 6e to the 3x. Okay, minus x we're being a bit lazy and we're just not writing this. Really it's minus 1 x to the power of 1, but we just didn't bother writing the 1s. So I'd have to increase the power by 1, so it must have been x squared. And then I've got to think to myself, right, 2 times something would have given me this minus. And remember, we can always just take this number here and divide it by the new power. So I could take minus 1 and divide it by 2 to be minus a half. So I'm going to get this minus a half down here. And the last one, so remember, ln x differentiates to give me 1 over x. So if I had ln 2x plus 5, I'd still get 1 over 2x plus 5. I get 1 over the function in the bracket. But because there's down here there's two lots of x, I have to then times it by 2. So whatever the multiple, whatever the coefficient of the x is in here, I'm going to have to multiply by that coefficient. So I'm going to get 1 over the function, 1 over 2x plus 5 times 2, and it'll be 2 over 2x plus 5. But in this case here, I've ended up with 4 over 2x. So there must have been something before here, because multiplied by the 2, I've had 4. So it means 2 ln 2x plus 5, because I've ended up with 2x plus 5 on the bottom, and I've ended up with 4 on the top, which is the 2 from here times by the 2 on the outside. So I'd have that for my third term. Then I'm plus c at the end. That's really important if it's an indeterminate integral. If I've got limits, if I've got those numbers, then I don't have to worry about the c. But if I haven't, I've got to put the plus c in, because there might have been a constant, and there might have been a number there. When I differentiated it, it disappeared. So when I integrate it, I have to make sure I put plus c to stand for that. So that's that. And finally, check this out. Whoa! What a cool program this is. Anyway, bye.